You should be on page 24 in your packet. Now that you've wrapped up the activity, hopefully you guys got through a lot of the POGIL on Coulombic forces. The general trend of Coulombic forces, as you guys probably noticed, is that the greater the Coulombic force, the force between the neutron or the nucleus and the electrons, the lower the radius. So we're going to translate now to, or we're going to transition to we're going to transition to electronegativity, and how we're going to relate Coulombic forces to that will hopefully become clear to you. Electronegativity is the third trend we're talking about. It is the same trend as ionization energy, although it doesn't mean the same thing. So the regular snowman applies to atomic radius, and the upside down snowman applies to ionization energy and electronegativity. Electronegativity, by definition, is the ability of an atom to attract an electron in a chemical bond. So it makes sense that ionization energy and electronegativity have a similar trend, because they kind of mean the same thing. If ionization energy is taking an electron away from an atom, electronegativity is the ability to attract an electron into a chemical bond or an atom. There's no real measure of this. It's kind of scientists kind of invented the scale. It's a range from 0 to 4. The higher the electronegative values present means that it's more electronegative. Since noble gases are not interested in exchanging electrons, they are not assigned electronegative values. So we leave them out of the trends. All right, moving forward. The group trend. As you move down a group on the periodic table, the electronegativity of an atom decreases. So as you move down a group, the electronegativity decreases. Which makes sense if we think about Coulombic forces, because as you move down a group, the radius is increasing, which means the distance between the nucleus and the electron is much greater, which means the force between them is low. So it doesn't make sense that as it gets bigger, it's good at attracting electrons. It's actually bad at attracting electrons if the element is large. Considering that trend, I'll go ahead and give you 1 minute. Why don't you answer this on your own? Which is more electronegative, nitrogen or phosphorus? And which is smaller electronegativity, fluorine or bromine? Go ahead and answer it on your own. All right, that's about a minute. If nitrogen is higher in the group, what that means is that it should be more electronegative, because we have a reverse snowman, so it's big on the top, kind of medium in the middle, and then really small at the bottom. So nitrogen should be more electronegative because it's higher in the group. For fluorine and bromine, we're looking for the one with the smallest electronegativity. Fluorine is actually the element with the highest overall electronegativity. It has a perfect 4. Okay, every other element is lower than that. So bromine has to be smaller. And also, if you're looking at the halogens, group 17, then bromine should have a smaller electronegativity. Let's talk about the period trend. So as you move across the period from left to right, electronegativity of an atom increases. So that means it's getting bigger as you go from left to right on the table. And remember, it doesn't include the noble gases because the noble gases in this case, they do not exchange electrons. So they're not good at attracting them. They're really good at holding on to them too. That's why they have a very high ionization energy. All right, I'm going to give you 1 more minute now. Answer the 2 questions again. All right, so the one that's less electronegative in this case should be furthest to the left. So if you're looking at carbon 6 and oxygen number 8, carbon is further to the left, so it is the one that is less electronegative. The greater electronegativity value should be on the right. Okay, so if you're looking at calcium and potassium, you can see that calcium is a little bit further right than potassium, so that's why it is higher. I want you to take another minute. Oh, sorry, we got to talk about the reason first. Go ahead and fill this in on your notes. This very much ties into what we talked about with Coulombic forces earlier. As an atom gets larger, the valence electrons are further from the nucleus, which means the nucleus pull is weaker. When they talk about a nucleus pull, what they're really talking about are the Coulombic forces that we just discussed, right? The attraction between the positive nucleus and the negative electrons. If that's really far away, the electronegativity is lower. The closer the electrons are to the nucleus, the higher the electronegativity. The more likely it is it can pull in more electrons. All right, take 1 more minute now. This last example, put them in order of increasing electronegativity. Remember to write big or small, big to small or small to big, whatever in this case it should be. I'll give you 1 minute to sort these out. Sorry, this is going to be a little messy. Probably wondering what the heck's going on right now. I'll explain in a moment. Okay, and we're back. So if we're trying to put these in order of increasing electronegativity, remember increasing is from small to big, not from big to small. So you're going to go small to big. You should be writing that every single time. And you're working your way from left to right. Okay, so from the left side of the periodic table to the right side. Since cadmium, Cd, is the one furthest to the left and the one furthest away from fluorine, it is the smallest one. And conversely, since chlorine is so close to fluorine, it should have the highest electronegativity. So if you're putting them in order, it should go from cadmium to iodine to bromine to chlorine. They should be in this order. The last thing we're going to do today is make a foldable. So each of you should have a sheet of white paper, and we're going to make a foldable that's going to look something like this. So I'm going to show you on a video now. That's what I was doing a few minutes ago. Okay. Oh, it's kind of sideways. I don't know how to fix that. All right, well, it should like kind of open like this. So I want you to take your paper and I want you to fold it in to make a trifold. I'll play it one more time. All right, if you want to see the video one more time, I'm sorry, bear with me here. There it is. One more time. So you see the idea is that it kind of opens up where the information is on the inside. All right, I have a more detailed picture here if you'd like to see it. Just open this up here. So the front of it should look like this, where you have the atomic radius with the regular snowman on the left, and the ionization energy and the electronegativity with the inverted snowman on the right. I'll give you about a minute to digest this picture and kind of write it down. Oh, you can leave the bottom left portion open. We're going to add to that next week with ionic radius, but we're not going to do that right now. I'm going to change it in about 20 seconds, but I'm also sending the slideshow to Miss Lewis if she would like to use it. Okay, changing. And this is what the inside should look like. So on the inside, you see the left trifold here. Oh, where's my mouse at? Can't see my mouse. Oh, geez. There it is. Okay. On the inside left trifold here, you can see there's a periodic table that shows you the trends. The largest element is francium. The smallest element is helium. And then in here, it provides the definition for atomic radius. On the right side, again, you have another periodic table that shows you the trend. And then the largest ionization energy is helium. The lowest is francium. And then it gives you the definition here. And then lastly, on the bottom right-hand corner, you have the electronegativity, the largest of which is fluorine, because remember the noble gases are not included, which is why there's that little column here that has an X on it to sort of signify that. And then it says it excludes noble gases. If you can't quite read my handwriting in the center, first of all, I don't blame you. It's pretty sloppy. Second of all, you can always look back at your notes and the definitions are there more clearly. Please hold on to this because we will be referencing this in the future, and there will be a quiz next week, and I want you to have this foldable kind of as reference. Ms. Lewis, if you could pause the video here, this will stay on the screen so that they can have a chance to copy it. And besides that, I'm out, guys. Have a good weekend, or have a good night. Sorry, geez. And make sure that you get lots of rest for the STAR test tomorrow. I know you guys are going to crush it. All right. Have a good day.